So, hi everyone, my name is Rohan. Today we are going to discuss the fluid catalytic cracking, where the cracking is basically the high hydrocarbons which converts into the high value products. The one of the process is fluid catalytic cracking. Now, from for the fluid catalytic cracking, uh, we add a residue, vacuum residue to the feedstock, uh, and feed is pumped and preheated take place in riser. Mm, Preheater take place in the riser with the regenerated catalyst. So whatever the regenerated catalyst and the fresh catalyst is there is mixed with the feed, and reaction take place in the vapor phase in such a way that the feed is charge take place in the reactor. So during this reaction in the riser, it residence time is 2 to 2 to 3 seconds. In 2 to 3 seconds all the cracking take place in such a way that the hydrocarbons are cracked, and these hydrocarbons is sent to the reactor. So residence, whatever the feed is there, that feed is uh, sender to the riser, and this riser, what the riser is do, uh, the it cracks the, during this process coke is formed in the catalyst pores, and it cracks in the presence of catalyst. So what the riser is do, the riser will, during this process cracking is take place, cracking, right, in riser. Now now the coking, now the coke is formed during this process, so the spent catalyst is sent to the regeneration react with the atmospheric air. Whatever the this feed is further fed into the reactor. In the reactor, in the reactor reaction doesn't take place. Yes, reaction doesn't take place, but separation is going to take place in such a way that catalyst and hydrocarbons are going to separate. Now the hydrocarbons are separated in the fractionated tower. Hydrocarbon are separated in the fractionator tower, and spent catalyst is sended in the, whatever the catalyst is there, it is sended in the catalyst stripper here. How it is done, two cyclones, like cyclone separator are there here. You can see in this, I will show you later the two cyclone separator. These basically separates the catalyst and uh, captures the hydrocarbon and it will send to the fractionator. And these catalyst is uses the sender to the catalyst stripper, and it uses the steam as the main uh, it uses the steam. uh, uh, it mixes it it e- actually the catalyst stripper is uses the steam to displace the hydrocarbons, and before sending to the regeneration, to prevent burning valuable hydrocarbons in generator. What is the purpose of catalyst is to prevent burning valuable hydrocarbons in regenerator, right? What is the catalyst st- stripper? Stripper will do mm, prevent hydrocarbons, right? Prevent hydrocarbons. And because this prevention of hydrocarbons, here pressure should be accurate, because if the pressure is imbalanced, air could go through that. Now the air hydro if the pressure is imbalance uh, in this spent catalyst section or this section, if then the hydrocarbons are could go in this way, and air could react with in the air could react in the riser, and this could cause the dangerous action. This could burn entire factory due to the because hydrocarbons are reacting with the air, and it will burn the hydrocarbons. So so to to balance, to prevent the hydrocarbon, we have to take care of the pressure in such a way that uh, pressure of uh, this could be the higher than the this, so that it can go from one point to another point. So in this process, the catalyst spent catalyst is going to the regenerator, and whatever the spent catalyst is there, we have in regenerator, they are react with the atmospheric air, and react with the atmospheric air, and uh, it could cause the two reactions. One is the carbon plus O2 gives rise to CO2, and carbon plus half O2 gives rise to CO. And in the fractionated section, whatever the heavy cycle oil is there and slurry oil can be recycled to the riser for further cycling, right? Whatever the heavy residue is there is recycled in the feedstock, and cracking take place in the riser, uh, so that further improved product will be getted, like lighter products, gas oil, gasoline, heavy light gas oil, heavy gas oil, right? Now, now the process summary is: coke is burned in the regenerator, the combustion heats the catalyst, hot catalyst provide the heat to vaporize feed and drive endothermic cracking reaction. No external fuel is needed except during startup. So the fresh feed is plus recycled oil is mixed with the hot catalyst, then riser cracking, then separates catalyst, then strip catalyst, then regenerate the catalyst, then it could repeat process in several times, right? So this is the main process. The next we are going to see, huh. Now the oil is cracked in the presence of finely divided catalyst, which is maintained in an aerated or fluidized state by the oil vapors. The crackers consist of catalyst section and fractionating section that operates together as an integrating processing unit. As you can see, that the catalyst section is this one, and fractionating section is this one. In the catalyst section we have the reactor and regenerator, and in fractionator we have only the fractionator. So the catalyst section contains the reactor and regenerator with the riser. From the catalyst circulation unit, the fluid catalyst is continuously circulated between the reactor and the regenerator using oil vapors and steam as a conveying media. So the preheated feed is mixed with the hot regenerated catalyst in the riser and combined with the recycled steam. Uh, Here they are said the it is preheated mixed with the hot regenerated catalyst in the riser and combined with the recycled steam. Now this recycled steam is came from the heavy fractionator, of the heavy residue, which is recycled back to the this feed, right? And it will react at the approx 500 degrees celsius by the hot catalyst. As the mixture travel up the riser, the charge is cracked at 0.7 to 2 bars. So the in modern FCC all cracking take place in the riser and reactor. Now today's, in modern FCC, riser and cracking take place in the riser and reactor. Holding vessel for the cyclones, cracker products is then charged to fractionating column, where it is separated into the fractions. Some of the heavy oil is recycled to the riser. Same we are discussed in the previous slide. So now the spent catalyst is regenerated in the regenerated reactor, and this process is done as I discussed. Carbon plus O2 gives rise to CO2, and carbon plus half more O2 gives rise to CO. And by heating that catalyst, we get the fresh catalyst, which is fresh hot catalyst, regenerated catalyst, which is further recycled or fed to the feed in such a way that it will react in the riser, and spent catalyst flows through the catalyst stripper to the regenerator, where most of the coke deposit burn off at the bottom, where preheated air and spent catalyst are mixed. Fresh catalyst is added and warm out. Catalyst removed to optimize the cracking process, right? Thank you. Thank you. Bye bye.